In this demo, I'll show how to create a REST API from a Cobol batch application using z/OS Connect Enterprise Edition in the WebSphere Optimized Local Adapter Service Provider. This demo is based on the z/OS Connect sample WOLA batch application available on GitHub. The Git repository contains sample Cobol source code, JCL, server configuration files, and API deployment instructions to replicate the demo scenario I'll show here. This demo assumes that z/OS Connect Enterprise Edition has been installed and configured with the WebSphere Optimized Local Adapter Service Provider, and that we have an Enterprise Cobol compiler available. The first thing I'll do is clone the Git repository to my local system, which I do by running the git clone command as shown in the README. After that, I allocate the necessary datasets on z/OS and upload the sample application files to my z/OS system. We'll begin creating our REST API by looking at the Cobol batch application which we want to REST enable. I'm going to use the IBM Explorer for z/OS as my user interface, but you could just as easily use a 3270 emulator. Let's start with a clean Eclipse workspace running an IBM Explorer for z/OS, which has the z/OS Connect API editor installed. The first thing we'll do is create a new connection to my z/OS system. After connecting to my system, I can look at the files I uploaded from my local Git repository. To do that, I expand MVS files, my datasets, then scroll down to the PDS into which I copied those sample files. The first thing we'll do is open the Cobol batch source code we're going to REST enable. We can see it has a program description area, including the WOL API flow used to connect to our z/OS Connect server and to receive requests and send responses using the WOL APIs as described. The application supports 4 distinct actions corresponding to the 4 HTTP methods we're going to support in our REST API. This application receives requests and sends responses which are based on the data structures defined in the 2 Cobol copybooks shown. So let's look at those copybooks for our requests and responses, which are defined in these 2 PDS members, zconrec and zconresp. Looking at the response copybook, you can see the kinds of data we keep about our employees: employee ID, name, email address, etc. An important field in our request copybook is the service request type variable. The value of that field determines which action is to be invoked in our Cobol batch application. The different values supported map to the 4 HTTP methods which our REST API will support: post, get, put, and delete. So by mapping different values for the service request type field in our API editor, which we'll show in a few minutes, we can control which Cobol code path is taken for each specific HTTP method used to invoke the API. You'll notice that we also provide sample compile link and run JCL. But the first step in REST enabling this application is to create a service archive and set of JSON schema mappings from the Cobol source code, request, and response copybooks, which is done with the BAQ ls2js utility which comes with z/OS Connect. If we look at the sample BAQ ls2js JCL, we see it's executing a Unix System Services script utility of the same name, which you control with a set of parameters as shown here. The output of this job is a set of files, including JSON schema files for the requests and responses, a bind file to map the JSON data to the backend Cobol copybook structures at runtime, and a service archive file which we download to our workstation and use to create APIs using the Eclipse API editor tool. Now let's look at my z/OS Connect server configuration using the z/OS Unix File Explorer, which I'll use to navigate to my server configuration home directory, which is in var z/OS Connect, servers, and server 1. Here you can see where I place the artifacts generated from the BAQ ls2js utility. The WSBind file is in data transform/bind. The request and response JSON schemas are in the JSON directory. And the Cobol service archive, or SAR file, is in the SARS directory. While we're here, let's look at the z/OS Connect server configuration, which is entirely contained in this server XML file. This file is where I define my services, my data transformation directives, and my z/OS Local Adapter Service Provider. I use this 3-part WOLA name along with this register name to communicate with my Cobol batch application. I've already started this server and the Cobol batch application running our service, which we can see by switching to the JES active jobs list. BAQ STRT is my running ZOS Connect server, and BKCOB is my running Cobol job, which we can see has registered using the 3-part WOLA name and register name we specified in our server XML. So the runtime is there. There's a running ZOS Connect server with a WOLA connection to our running Cobol batch application, which we've defined as a ZOS Connect service. Next, we're going to create and deploy our APIs using that Cobol batch service we just defined. So I'll switch Eclipse perspectives to the ZOS Connect Enterprise Edition perspective. This brings up a Project Explorer tab, as well as a ZCEE Servers tab and a Host Connection tab. We'll begin by adding a connection to our running ZOS Connect server in the Host Connections tab. When we save and connect, we're prompted for the user ID and password, which we've defined in our ZOS Connect server XML file we just looked at. Once connected to our ZOS Connect server, we should see a green dot next to server 1, and we should see that the new server is shown up in our ZOS Connect servers tab. Notice that we don't have any APIs deployed to the server yet. So at this point, we have a decision to make. We can either create the API project from scratch, or we can import the example project from the Git repository. For this demo, I'm going to import the Eclipse sample project from the Git repository. I'll demonstrate creating APIs from scratch and dynamically updating them in another demonstration video. To import the Eclipse sample API project included in the Git repository, we right-click in the Project Explorer tab, Import, General, Existing Projects into Workspace. Here we browse to our Cobol service.zip file, which should be out in our local Git repository, and click Finish. Let's explore the API project before we deploy it to the server. The API definitions in the ZOS Connect EE project are stored in the package XML file. So if we double-click on that file, the ZOS Connect EE API editor opens up. Our API project is called Cobol Service and has a single path defined for our employee API, which can be invoked using 4 different HTTP methods corresponding to each of the REST operations of POST, GET, PUT, and DELETE. You can see that we are assigning the same Cobol service to each method. We can do that because we have a single entry point in our backend Cobol application code which looks at that service request type field in the request copybook to decide which action to take. We can assign that value and control our other JSON to Cobol mappings using the API mapping editor. So let's start with the POST method mapping for requests. This is where we can customize the default JSON to native language data structure mappings which were generated with the BAQ ls to JS utility we ran on ZOS earlier. The mapping tool shows our REST to JSON request data on the left and the Cobol data structures from our copybook on the right. Looking at the Cobol data fields, we can see that we have assigned specific values for 2 of our fields, service request type and service request filler. If we highlight the assigned transformation for the service request type field, then look at the value set for that variable in the Properties tab, we see that we are hard-coding a value of P for service request type and omitting it from the interface. So our REST clients won't see the service request type field. If they call our API with an HTTP post, ZOS Connect will set service request type to P when the Cobol application is invoked, causing our application to go down the code path responsible for creating a new employee. This is also where you can access HTTP header data and path and query parameters if you have those as part of your API definition. Now let's look at the mapping for response messages of API invocations using the POST method. We can see that on the POST response, in which we are creating a new instance of an employee, we are removing all fields in the service response data structure, which contain the employee details which were just sent in on the request. We'll only return the service response status data structure, which includes the response message and type. So we have the same type of thing going on with each of our other methods, get, put, and delete. Feel free to open each mapping and inspect for yourself. So let's assume that this is exactly how we want our API to behave. Our next step is to deploy it to our ZOS Connect server and test it. Deploying APIs to the ZOS runtime is really pretty straightforward. You simply right-click on the API project to deploy, select ZOS Connect EE, and deploy to ZOS Connect EE server. Then we click on OK and wait for the API successfully deployed message. We should now have an API under Server 1 in our ZOS Connect Servers tab. To test that API, we can use the Swagger User Interface tool. To do that, we right-click on our Cobol Service API and select Open in Swagger UI. If I click on List Operations, I can see the 4 methods that we have defined for our API. So let's start the process by creating a new employee record by clicking on our Post method. We can then scroll down to the Parameters section. If I click in the Example Value section for the Post Cobol Service request, the JSON body for our request gets populated with some sample JSON data. I can then update each field, changing string to something meaningful. So I'll type in values for email, employee ID, remarks, employee name, and phone. Once I have everything set up, I click Try It Out. And I should get a response body back showing the service response status fields, showing that the record was added using the post service request type. I can test an HTTP GET invocation of my API really easily, since I don't require any JSON data in the HTTP message body to call it. Just a simple HTTP GET will do. I just click on GET and try it out. And I can see the values I just used to create my employee record with the post invocation. This concludes the Getting Started demonstration of using ZOS Connect to REST enable a Cobol batch application.